Okay, number 12. It's got a little twist. That's why I wanted to do every one with you, because they all have something different about them. And if you've never seen it before, you wouldn't know what to do. There's a couple of ways you could tackle this problem. Can't find my blue pen. I'll just go with purple. Okay. Now, the function f of x has only got 3 terms, but he's got a power of 4. So there's some terms that have zeros for coefficients. There's 2 ways you can tackle this. Well, at least 2 ways, more than that even. That you can see a factor pattern because there's 3 terms, and that could be considered a trinomial, a common trinomial. But depending on your factor experience, you would see that. But if you don't see it, you go ahead and make your m over n, which is that. I'm going to show you that one for these notes, and then I can show you the shortcut if you want it, you know what it is. Otherwise, m and n's just as fast. M over n is positive and negative 1, 2, and 4. So not too many choices. Over positive and negative 1. You just have to remember when you do your synthetic division, though, you have to have a coefficient for each power. So if I want to divide by 1, I have to have the 1 for the 4th power, 0 for the 3rd power, negative 5 for the 2nd power, 0 for the linear, the 1st power, and then 4 for the constant. See the trick? And it's not a trick. The reason you need that is when you divide, you need it's like a place value when you're doing long division. There's not a value there, you put a 0. So it's you know, they don't just make these rules up. They all come from the rules of the universe. It's really cool. I multiply, then add, multiply, then add, multiply, and celebrate that that equals 0. Now, because it was a 4th power, I still have x to the 3rd left. So again, there's a direction you can go. If you see a pattern, you could factor. But if you don't see the pattern, then you would just keep dividing. Okay? So this morning I showed the pattern, but I'll just keep dividing because more than likely you wouldn't see the pattern because of your experience. You know, you haven't done it for years and years and years, but you might see it already. That's okay too. So 1 worked once, number 12, there's 4 spaces, so there's 4 different answers. So I'm not going to try 1 again. I'm going to try a negative 1. Oh, I got to use my new. I guess I can use my old ones, but that's not going to help me get to the factory. So I'm going to use my new coefficients. Okay? You with me? The old worked once. Now I'm going to use the new coefficients from this is a quotient of this is a polynomial quotient, so just going to use synthetic division again. Multiply. Yeah, got a 0. Multiply, got a 0. Add, multiply, positive. Yep, it's another answer. So we've got a 0 of 1 and a negative 1. Now this guy we can factor. It's x squared plus 0x, so I don't write it down, minus 4. So right now, we don't have a common trinomial. We have the difference of squares. So depending on your decisions, you get the same answer. It depends on whether you want to factor quickly or factor last or factor whenever. So I'm just going to wait till the end to factor here. So now we've got factors of x minus 2 and x plus 2, because both terms are perfect squares. And that'll help me finish part one. Part one, I have to grab my, I have to grab my answers I got from division. It says the zeros are, and they don't use an E here. One of the questions had an E between the O and the S, and the other one didn't. So potato, potato. So 1, comma, -1, comma, 2, comma, -2. So in part one, you pop these in the boxes. After all that hard work. Part two. Says the factored form of the function f of x is, that is a factor, x minus 1. That is a factor, x plus 1, x minus 2, x plus 2. Here we go. So each one of those have their own little boxes. Don't put them all in one box. It doesn't like that. Okay, put them in their own little boxes with the parentheses. All the notations. That was fun. Now you know what, and I'll go ahead and show you. If you notice, this can be factored into x squared minus 1 times x squared minus 4. See? Then you could have factored it to x plus 1, x minus 1, x plus 2, x minus 2. So that's how fast it could, if you see a factor pattern, that's how quickly you could come up with the part 2, and then the part 1 comes from, the zeros of those factors. So if you happen to notice that, it's right. Those factors of 4 when added give me 5, and they're both negative. They happen to be perfect squares. What a fun polynomial. So that's the shortcut. Okay. So depending on your factor experience again, you see those things. Okay, 13, we're just going to be drawing pictures and writing formulas, and we don't have to write down all the words. It says a laboratory supply company is designing a new rectangular box. So I'm going to draw myself a box. It's rectangular. So make myself some rectangle-ishes. There we go. In which to ship glass pipes. The company's design team, has created a box with a width 2 inches shorter than its length. So this guy, I'm going to call that the width. The width is 2 inches shorter, so I'm going to take a 2 away from the length. And the height, 9 inches taller than twice its length. So this is a poor rendition of the box, because technically this height is supposed to be 9 inches taller, so that's plus 9, twice the length. And this guy will be the length there. So I got my cursive L going on. So they're all in terms of the length, according to the story. So I just changed the words to a mathlish right there. The volume of each box must be 45 cubic inches. And you know how to find the volume of a box, I hope. Length times width times height, one of my favorite calculations. And this is where the polynomial will come in. So you could substitute these with the other expressions for volume was 45, length was length, width was length minus 2, and height was 2 times the length plus 9. Yeah. Looks like a good ACT problem. So I could multiply this all out, move the 45 to one side, use synthetic division, and did all that hard work. But instead, I can use my common sense and say, well, what if I tested some measures to see which one made this true? Now, obviously, the length can't be 2 because it would make the box be 0, okay, for the width. That's not possible. So let me test if length can equal 3. See if it comes out to be 45. And this is the workaround to doing all the polynomial math. Now, we can do this because they gave us a set volume. And if you were in the lab and you were just looking at your possibilities, you'd graph this using an online technology. You could just put these three, you put x minus 2, and 2x plus 9 in your polynomial box, and it'll show you the possible lengths and widths and heights you could have for a box. Pretty cool. Okay, so I'm going to put a 3 in here. So does 45 equal 3 times 3 minus 2 times 2 times 3 plus 9? So I'm testing it to see. So I have 3 times 1 times 6 plus 9 is 15, and sure enough, it does. So, watch out. On your software, your measures might not be in the order of mine. My measures ask for the width first. So my width came from here. Can't see it. Up here, I put 3 minus 2. So width is 3 minus 2, which is 1. And then it asks me for the length, which we tested and checked that 3 worked. And then it asked me for the height. Oh boy. Missing my purples diet. Okay. And the height. Oh, pickles, come up here. And the height was 2 times 3 plus 9, which turned out to be 15. So in my software, I got to make sure my values match my dimension, because yours might be in a different order. So be careful, okay, when you're entering. If I remember from years past, people just copied my numbers in a row, and they got it wrong, and they couldn't figure out why, because they weren't paying attention to what their software asked for first. Okay? Alrighty? So that's your beware on 13. So that's not so bad, is it? It's a good application. Volume is a 3-dimensional measure, so that's why they're using them for polynomials in this lesson. Okay? So everybody figure out their appropriate measures. We'll move on to number 14. 14th story has to do with a pyramid. I love pyramids, and when I taught pre-algebra, I had to have them experience why the pyramid formula was the way it was. We took a rectangular prism, and we took a pyramid, and we found out that had the same height and the same base. We found out how many pyramids fit into a rectangular prism with sand, and it ended up 3 of them fit into the rectangular prism. Well, the rectangular prism is length times width times height, but then a third of it is how you got the pyramid. So that's how I remember, because I felt the sand. Took my sandbox home, but I hope you had that kind of experience when you worked with the different formulas. This guy, he is a triangular pyramid. I think my aqua one, I don't know what I did with, oh, here he is. He's a pentagonal pyramid. But this one, that we're doing in our story, he says 14's got a square base and 15's got a rectangular base. So technically, they would just have the capital B here. Because if it wasn't a square or rectangle, you have to have that formula for the base. But I'll read you the story. 14. A natural history museum is building a pyramidal glass structure for its tree snake exhibit. Its research team has designed a pyramid with a square base. So here's my square base. And a pyramid, you just put the dot above it. You guys artists, right? Kind of ish. And then the height goes down to the middle of the base and it's perpendicular. Pretty sad piece of, that's not even a square, but we'll pretend it is. Okay. The height is 2 yards more than the side of its base. So we're using, since it's a square, we got S times S. So the volume of the pyramid must be 147 cubic yards. So the 147 is 1/3 of the side. That's an S, okay? Times the side. That's the length times the width times the height, which is 2 more than the side. So we're going to have to come up with a number. When we multiply it together and divide by 3, we get 147. I'm going to make it a little easier on our guessing and checking. I'm going to go ahead and take it times 3, so it's 441. So it's S times S times S plus 2. So, somebody have a guess what we could test? What would a good S number be? Somebody have a guess? There's no, it could be a 1, right? There's no minimum. It's got to be positive. But there's no subtraction in here to make us have a limit. So, what do you have? But 1 obviously is way too small. Do you have a guess? It's got to be a strange number because when you multiply them together, you get 1. So it can't be like a even numbers. So what's 1 doesn't work. Do we have a guess? What's your guess? What would you try? Shout it out. Anybody have a guess? Go ahead, it can't be wrong. You know, if you are wrong, then that's just 1 less that it isn't. It's okay to be wrong. So, okay? 3. Okay, let's do 3. So that would be, does 441 equal 3 times 3 times 3 plus 2? And that's, you needed an odd number, right? So, 9 times 5 falls short. So thank you for guessing. Somebody got a little bigger odd number? If you multiply by 5, that ends in a 5, and 441 doesn't end in a 5. So what's the next odd number? Which one? What's next to odd number? 7. Let's try 7. Thank you. 441. Does that equal 7 times 7 times 7 plus 2? So that is 49 times, that's 49 times 9. Does that equal 441? It sure does. So it only took us a couple of guesses, and that's okay. You know, you had to have some number sense. That's a good thing. That's a good practice, especially if this was an ACT problem and you had choices, you know which one's reasonable. Okay, so that means the height, it asks for the height first on my software. So again, be careful which one they're asking for. The height was the bigger number, 7 plus 2, which was 9. And the side was 7. So there you be. So make sure you put the right value for the right dimension. So you get it right and you miss it. Oh, pickles. You know the frustration of that. So pictures are powerful when you're working with the word problems, if you notice. And then you write your little math list and come up with the formula, which number 15 is a pyramid as well. You already know the formula. It's a rectangular pyramid, so the base is a rectangle. It says a paper company is designing a new pyramid-shaped paperweight. Its development team has decided to make the length of the pyramid paperweight, 4 inches less than the height. You guys good with writing that as an expression? And the width is 3 inches less than the height. So when I grew up, I thought the length was longer than the width, but not in this case, and that's okay, whatever. There we go. It's just old school for me. Did you guys learn that way? That the width was always shorter in your brain? No? No difference? Okay, it's probably just me. All right, so the height was coming straight down here. So the height is the one we don't know. We need to know the height. It's all behind. Have fun with it. Color it. Feel the paperweight. Okay, it says a paperweight must have a volume of 12 cubic inches. So that is the volume side of the formula. 1/3 of the height times the length times the width. And can't be 4. Got to be more. If it was 3, that'd be a 0. And it's got to be positive. If it was a 2, I'd have 2 negative numbers. So you can't have negative measures. So I have to start with the number after 4. So let's try h equals 5. Again, you can do the you can move the 3 up here if you want, or just leave it where it is, whatever you want to do. 5 times 5 minus 4 times 5 minus 3. So it's 12 is 1/3 of 5 times 1 times 2. And that's a no, because 12 does not equal 10/3. I see what I did? I can try h equals 6. Does 12 equal 1/3 of 6 times 6 minus 4 times 6 minus 3? So 12 equals 1/3 of 6 times 2 times 3. 12 equals 3 cancels 12. Yes. So in my software, it asked me for the length first. And in the story, it says that length was h minus 4. And h we found to be 6. So 6 minus 4, which equals 2. The height is 6 itself. And the width is 6 minus 3, which equals 3. So and yours might be in different order, so be careful. Length, height, and width. Go. So those were fun. We bypassed the polynomial equations, but you could see where polynomials show up, emerge in real life. Okay? And in real life, as if this isn't real life. Just polynomials just create so much information for you. So much is based on polynomials. The size of your clothes, the height of this room, the intensity of the light, da 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 da. How many outlets are in the room? You know, polynomials are behind a lot of physical construction that makes us comfortable and healthy. We're blessed. Okay, number 15. 16. Last one, it's a drag and drop. They give us a little, it's back to what they have us here do is discover the relationship between the function, what is called f of x, good name, and its zeros. So the zeros, you're going to do the drag and drop. And what they want you to hear, they have the E in the zeros word. Okay. F of x r x equals. And hopefully we're all in tune where we get our zeros from. What makes that zero? That factor, set it equal to 0 and x is negative 2. The next factor, set it equal to 0 and x is 4. Last factor, set it equal to 0 and x is 3. So they're going to give you these numbers with positives and negatives. Just make sure, you know, you have the right signs. Hopefully, through our days of practice, you've got scoop where we get what sign or answer is. Got to be opposite because our goal is to make this a 0, and that's why they're called zeros. Now the next part of the question wants you to go back to the standard form. They gave it to you the factored form. So the standard form, they did all the hard work. They have all the terms here, x cubed minus 5x squared. They did all the multiplication, minus 2x like you did last year. But they want you to fill in the constant term here because the zeros of all the factors are all the factors of the constant term. Ah, pickles. Lost my eraser. So that's where this comes from. So I go up here to the constant terms and I multiply them together. 2 times a negative 4 is a negative 8 times a negative 3 is a positive 24. So that's how I know what goes in here. And it is a positive number because these three are factors of 24. Yahoo! That is the last discovery problem. Now I held your hand a lot, but this was a lot because if you are missing any of these skills, it would make it very difficult to be successful on this lesson. So that's why I wanted to support all the factoring and the number sense and the procedures and the strategies and all that. So hopefully you feel completely supported for this lesson.